Okay, so let's talk about bioequivalence. In Pumas, we do support bioequivalence, and we have several crossover designs that we support. If you go to the documentation and you go at basics and Pumas B, down here, bioequivalence, quick start, designs, you are going to take a look at the different designs that we support. We have 2x2, Balan, Duo, Inner, Out, Williams 3, Williams 4. And this is the number of our formulations, number of periods, number of sequence, and an example. For example, the 2x2, it's we have 2 formulations, 2 periods, and 2 sequence, and they're not replicated. And the example is when you have like a reference test followed by a test and reference. So that's the idea. And let me showcase to you in our Pumas. So I'm going to be using Pumas, using Pumas utility, bioequivalence, and also Prama datasets for our dataset. Our dataset is a best dataset called bioequivalence. And this is the dataset. As you can see, we have a column ID with the subject ID, the sequence, which is a string. So this is the reference test, and then test reference, and the period. And we have 2 endpoints here for the bioequivalence, AUC and Cmax. So once you have that data set loaded, it's a data frame, we get back. But we can use our Pumas V function. So the Pumas V function, if you hover over the documentation, it takes a data frame, and then it has several keyword arguments with default values. Some of the defaults, like the sigma W0 and the delta, they are defaults they are good defaults for most of the bioequivalence tests. But if you want, you can also override those. And of course, if you have a different column for ID, sequence, period, you can also specify those as column names here in your data frame. By default, our endpoint is the AUC. So here we are using the max as the endpoint. The ID column is the ID, the sequence is the sequence, and the period is a period. And when I run this, I get back bioequivalence, where I have the GMR, the geometric mean ratio, the lower bound, upper bound, and the log for all of those bounds also. Now, to use the endpoint as an AUC, you just change the endpoint for AUC, and if you run this, you get back a bioequivalence using the AUC as endpoint. So you get the same summary, the same table, GMR, lower bound, upper bound, and the log of both lower bound and upper bound. Now there is one caveat. By default, our method that we use is the FBA method. But if the endpoint is Tmax, then we are going to using the non-parametric method. So this is the only caveat in the calculation of our bioequivalence. So this is how you perform bioequivalence in Pumas.